All right. So we're going to do the conductivity of solutions, and again, conductivity is how well something conducts electricity. And to briefly demonstrate this, I've got some water right here, as filtered as we can make it, and then I've got our sodium hydrogen carbonate right here, and our sodium carbonate right there, and we're going to hit it with some electricity. Specifically 110 volts AC. I have one of the oldest bulbs in the world right here. Old 60-watt incandescents. All right, so don't touch these things together. You touch one, don't touch the other one. If you do, zappy. Okay. So this is what happens when it's in normal filtered water. Deionize as much as we can. And then this is what happens in the sodium hydrogen carbonate and the sodium bicarbonate. Can you tell the subtle difference? Yeah. Sodium hydrogen carbonate, sodium bicarbonate. So which one's brighter?
Sodium bicarbonate.
Yeah, sodium bicarbonate. Just by just a little bit though. It's not like wham, but yeah, definitely a little bit. So there are simply more ions in the sodium carbonate to zoom around. So that's what you're going to do. You're going to make a solution of a mixture. You're going to make a solution spectrum. So in your lab, you're going to say, all right, I'm going to make 6 solutions. 1 and 6 are already done for you, really. So for number 1, it's going to be all sodium bicarbonate. Number 2 is going to be 8 milliliters of sodium bicarbonate and 2 milliliters of sodium carbonate. And then 3 is going to be 6 and 4, and then 4 and 6. So what you're going to get is a spectrum going from all sodium bicarbonate to all sodium carbonate. Okay? And then that's going to give us our conductivity. We're going to basically plunge the conductivity meter into the solution, and it's going to give us a number. And hopefully the number will create a spectrum that we can then graph. And we're going to slap the graph on here somewhere. Okay? So far, so good? All right, again, I would recommend using Desmos. This is the first year. I just learned about Desmos this summer. I would recommend filling this table out and then making this in a Desmos table for conductivity. So you could be like concentration of one of them versus conductivity, concentration of the other one versus conductivity. You pick. Okay? Concentration of sodium bicarbonate versus conductivity, concentration of sodium hydrogen carbonate versus conductivity, then you'll have a graph. Because what we're going to do is, later on, tomorrow, Monday or Tuesday, is we're going to make a solution of this, our unknown, and then figure out where it falls in the conductivity graph, which should give us a pretty good idea about where we should be. Does that make sense? So calibration graphs are very, very handy. All right, so our conductivity meters are back here. They are pretty simple. They do need to plug in. So the conductivity meters are right here. So there's a meter, there's a little sensor. The instructions say it's 20,000, it's right there. They do need to plug in to LabQuests. So these are LabQuests. Turn them on, and then they plug in, depending on whether it's analog or digital. They plug in right here, and then the conductivity is given to us in micro somethings per centimeter. I don't remember what that's called, but anyway, so there you go. Yeah, cool. So let's go ahead and test our conductivity meter. And again, just by moving it through the air, it's actually picking up some ions. So I'm at 202, 217, 250. These do take a little bit of time to warm up. And then 25,000, 26, or 2,600, and 36, 44, 4,500. Make the idea? Make sense? So that's what you're going to do. You're going to make your solutions, and then you're going to plunge the conductivity meter into your solutions and write down their conductivity. Okay. Now, how do you use these? How to make the best way to make these solutions we talked about whole milliliters is with a pipette, with glass pipettes. We don't have glass pipettes, but we have these really cool little syringes, graduated at 5 milliliters. So if you need 4 milliliters, just stick it in there, get all the air out. Whoop, 4 milliliters. Word. Cool. And if you need some more liquid vinyls, I can grab a bunch of these for you too. There's a bunch back here too. Just make sure you rinse them out really well first. Okay, questions? All right, so once we have completed that, and somebody left a nice little pen. That might be mine. Anyway, so once we have completed doing the conductivity, see if you can figure out, once you've got your conductivity graph, you're gonna post your graph under here, see if you can figure out what the molarities are. Okay. So yeah, see how much of that you can do. If you get stuck, that's okay, we'll come back to it and talk about it hopefully at the end of class. Questions?
So we're only doing the conductivity column right there?
Yes.
And then number 4, is that something we just calculate on paper?
Yes, but you're working here too. So again, do number 4 when you can. And then at the end of class, we'll come back together and we'll like, did you get this? Did everybody get this? Okay, what does that mean for this? Okay, cool. All right, so go get your conductivity, get your solutions made, get your conductivity done. One set is already right up here. You can take this if you want. Oh, and don't walk in front of the camera because I'm going to be live streaming this whole time so I can live stream the calculations we do too. Just gonna let it go. Let Google capture 40 minutes. You know what? Quick change of plans. There is better options right now. These are better for making your meetings. So grab like 5 or 6 of these. That way you don't have enough volume where you can keep the connectivity going better.
Yeah, we did stick it. But I'd say we make the.
Should we save and label all of the solutions?
Save? No. Label? Yes. Kind of a just in case thing.
What do we do once we have the conductivity numbers?
Do number 4 for this, the concentration, and see if you can do the other concentrations too. And once we are there, we'll get back together and talk about it. Okay, of course. Have you worked on number 4 yet? Get the concentration of that down. hope I fixed the letter. I hope she's going to give me a 5-minute warning. Okay, so this is where we're going to start running our concentration. So once again, concentration, molarity is going to be moles over liters. So our first step is to figure out how many moles of each thing we used, right? So, so 0.02 divided by 10, no, is it? Divided by, oh, geez, is this 1, 106. Why does this keep happening? I hate it. This thing has a bad screen. And for some reason it keeps ending up in the stack.
Shouldn't it be 0.2 grams? That's what.
Was it 0.2? 0.2, yes, thank you. Yeah, 0.02 would make, that would be extremely hard to measure. Thank you. 0.20, 0.20, thank you. All right, so 0.2 divided by 106, 0.2 divided by, 106. This ends up being 1.89 times 10 to the minus 3 moles. Is that what everybody, oh, you're probably,
Yeah.
0.2 divided by 84, that's going to be 2.38 times 10 to the minus 3 moles. Okay. And then to find the concentration, we're simply going to put that over 100 milliliters, which is 0.1 liters. So that over 0.1 liters gives us a concentration of 1.89 times 10 to the minus 2 molar. That over 0.1 gives us a concentration of 2.38 times 10 to the minus 2 molar. So far, so good? Okay. And now it just becomes proportions, which I could write on the screen over here, but I can't. So this is going to be the concentrations for test tube 1, or test 1 is going to be all sodium hydrogen carbonate, so 2.38 times 10 to the minus 2, and 0. And then experiment 6, or test 6, is going to be all sodium carbonate, so it's going to be 0 and 1.89 times 10 to the minus 2. Make sense? Then to get experiments 2, 3, 4, and 5, you're going to multiply this by 2/10. See, it's experiment 2 is, this is 2/10, so 2/10. This is going to be 8/10. Oh, wait a minute, hold on. Back up. Did we do that? Because we added them together, right? Yeah, we could. They have the same volume. If they have the same volume, you can do that. If you add two solutions together that don't have the same volume, you can't do that. Because you have to take the number of moles and divide by the new volume. But since they're going to have the same volume, I think we can do that. Okay. And then 3 is going to be 4/10 and 6/10. And 4 is going to be 6/10 and 4/10. Do that. Diluted to 6, diluted to 10, and then 8/10, 10. And 2/10. That should give us the spectrum of concentrations, I hope, if I'm doing my math right and reading it correctly. Oh, yay, it's working. I don't know why it stopped working. I had to completely reprogram it, but it's working now. Alexa? Thank you.
You're welcome. Enjoy your morning.
Alexa, cancel. There we go. Mind if I pop over to anyone's shoulder and take a look at your graph? Or take a look at the numbers away? Oh, yeah, cool. We got the same thing. Oh, yeah, that's great. Okay. It is exactly what we would expect it would be. More conductivity with more ions. If we want it to be exactly proportional, exactly 2/3 or exactly 3/2, we would have to calibrate the conductivity tester, but we ain't gonna do that. We're just gonna throw a little thing on there. Are you done?
Yeah, with the polarity part.
Measure out 0.2 grams of this and make a solution.
What's your pursuit?
Yes, 0.2.